Hello, my name's Dr. Richard Sharp. I've followed the development of climate change for over 30 years, but with increasing concern. And it wasn't until last year I realised that scientists had told politicians and leaders of industry some 60 years ago of the dangers we faced, at a time when I was 10 years old. I'm not a climate scientist, I'm a retired research microbiologist, but I've got a vested interest in doing something to combat climate change. My oldest grandson, Joe, is 10 years old, and when he reaches my age, it'll be 2080. The future for his children and grandchildren are in the hands of my generation and his parents' generation. The first part of this talk looks at the period from 1826 to 1990, a time when scientists studied and monitored the planet's climate systems and began to understand the impact we were having on them. Part 2 looks at the last 30 years and the way world leaders and politicians have chosen to deal with the knowledge scientists presented them with. Hardly a month goes by now when a climate record somewhere in the world is not passed. On July the 25th last year, the United Kingdom's hottest temperature on record was measured at 38.7 degrees centigrade in the Botanical Gardens in Cambridge. Last July went on to be one of the hottest Julys on record, with 9 of the hottest Julys in 140 years, all being recorded since 2005. Last December, the United Kingdom recorded its hottest December day at 18.7 degrees centigrade at Achfarry in the Scottish Highlands. And not to be outdone, on December the 18th last year, Australia celebrated its hottest day. 2019 became Australia's hottest and driest year on record. On the 6th of February this year, Antarctica recorded its hottest temperature at 18.3 degrees centigrade. 2019 became the second hottest year ever recorded. In fact, the last 5 years are now the hottest 5 years since records began. The average temperature now is almost 1 degree higher than the average for the period 1950 to 1980. The UK recorded its wettest February on record earlier this year, and it was the 5th wettest of any month recorded since 1862. By the 4th of March this year, record Australian bushfires destroyed more than 12.6 million hectares of bush, an area equivalent to half the size of the UK, producing somewhere close to 434 million tonnes of carbon dioxide. Extreme weather events across the world, such as heat waves, droughts, floods and storms, have sadly become accepted now as the new normal. Our understanding of climate change and the greenhouse effect has developed from research from 4 19th century scientists from France, the United States, Ireland and Sweden, and each of them played a key role in laying the groundwork for our understanding of the greenhouse effect. Jean-Baptiste Joseph Fourier was a French mathematician and physicist, and he considered that the temperature of the Earth with no atmosphere would be much colder. He realised the Earth's atmosphere returned heat radiation from the Sun, keeping the planet warmer than would be the case in a vacuum. He realised the Earth's surface emitted invisible infrared radiation, which carried the heat energy away into space. And he also suspected human activities could influence the climate. At present, roughly 30% of the incoming solar radiation is reflected back to space by clouds, aerosols and the surface of the Earth. Without naturally occurring greenhouse gases, the Earth's average temperature will be much nearer to minus 18 degrees centigrade instead of the much warmer average 15 degrees centigrade. Eunice Foote's contribution to climate research has only been known since 2011, when a retired petroleum geologist, looking through old scientific journals, came across her paper in the 1857 journal Annual Scientific Discovery. Eunice Foote studied the interactions of the sun's rays on carbon dioxide, the air and hydrogen, and she concluded that carbon dioxide trapped the most heat and considered that an atmosphere of carbon dioxide could give the Earth a higher temperature. Her research paper, entitled Circumstances Affecting the Heat of Sun's Rays, was presented at the 8th Annual Association for the Advancement of Science meeting on August the 23rd, 1856, in Albany, New York. John Tyndall was an Irish scientist and he investigated the absorption of infrared radiation in different gases. He found that water vapour and hydrocarbons like methane and carbon dioxide strongly block infrared radiation. He understood that such gases high in the air helped keep our planet warm by interfering with the escaping radiation. Tyndall went on to become Professor of Physics at the Royal Institution at London. In 1896, Svante August Arrhenius, who was a Swedish scientist and was one of the founders of the science of physical chemistry, attempted to develop a theory to explain the ice ages. He estimated the extent to which increases in atmospheric carbon dioxide would increase the Earth's surface temperature through the greenhouse effect. He subsequently concluded that carbon dioxide emissions from fossil fuel burning and other combustion processes were large enough to cause global warming. Arrhenius's work is seen as the first demonstration that increases in carbon dioxide would cause global warming. We now know that from the time Fourier published his work in 1824 and Arrhenius published his work in 1896, atmospheric carbon dioxide levels had risen from 284 ppm to 295 ppm. If you're unsure, ppm stands for parts per million. It's often used to describe the concentration of a chemical. A carbon dioxide concentration of 295 ppm means that in 1 million particles or molecules in a sample of air, 295 of them will be carbon dioxide, while the remainder will be mainly oxygen and nitrogen. Without naturally occurring greenhouse gases, the Earth's temperature would be near to minus 18 degrees centigrade instead of the much warmer, steady 15 degrees centigrade. Naturally occurring greenhouse gases, carbon dioxide, methane, and nitrous oxide, normally trap some of the Earth's heat, keeping the planet from freezing. Human activities, however, such as the burning of fossil fuels, are increasing the levels of these greenhouse gases, leading to an enhanced greenhouse effect, and the result is global warming and unprecedented rates of climate change. By 1938, atmospheric carbon dioxide levels had risen to 311 ppm. And that year, Guy Callender, a British engineer and amateur climatologist, attempted to demonstrate that the Earth's temperature was rising. In 1938, he published a paper compiling measurements of temperatures he had collected from weather stations across the world from the 19th century onwards. He concluded that over the previous 50 years, global land temperatures had increased, and he tried to correlate these with old measurements of atmospheric carbon dioxide concentration. And he proposed that the temperature increase was an effect of the increase in carbon dioxide. His study was treated with a degree of scepticism, but in later years was shown to be remarkably accurate, and his papers did convince other scientists of the need to conduct an organised research programme on carbon dioxide concentrations in the atmosphere. Gilbert Norman Plass was a Canadian physicist, and in 1953 he told Time magazine of his work on the effects of carbon dioxide from industrial sources as a greenhouse gas and the implications increased concentrations of carbon dioxide would have for global warming. From 1956 onwards, he published a series of papers, partly based on advanced calculations of the absorption of infrared radiation, and he made use of early electronic computers. Plass's predictions for the increase in global atmospheric carbon dioxide levels in the 20th century and its effect on the average temperature of the planet closely matched measurements reported half a century later in the 2007 IPCC Fourth Assessment Report. There had been uncertainty where the carbon dioxide produced from burning fossil fuels was going. Arrhenius and Callender both considered it would reside in the atmosphere, but others considered the oceans would absorb most of it. In 1957, Roger Revelle and Hans Schuss from the Scripps Institute of Oceanography attempted to determine the proportion of carbon dioxide emissions which remain in the atmosphere and the proportion which becomes dissolved in seawater. They used carbon dating, which had been developed in the 40s, to compare the ratios of carbon isotopes C14 to C12 and C13 to C12 in wood and marine-based material. Based on a slight decrease of the carbon-14 concentration in terrestrial plants over the past 50 years, they concluded that the average lifetime of a carbon dioxide molecule in the atmosphere before it's dissolved into the sea is in the order of 10 years. They considered most of the carbon dioxide released by artificial fuel combustion since the beginning of the Industrial Revolution must have been absorbed by the oceans. The increase of atmospheric carbon dioxide at that time, 1957, was considered small, but they considered it may become significant over future decades if industrial fuel combustion continues to rise exponentially. They concluded that human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past or been reproduced in the future. Within a few centuries, we are returning to the atmosphere and the oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years. 2 months later, scientists in the research division of Humble Oil published a similar study called Radiocarbon Evidence on the Dilution of Atmospheric and Oceanic Carbon by Carbon from Fossil Fuels. Humble Oil was a precursor to Exxon. It's clear now that in 1957, Humble Oil were fully aware that burning fossil fuels was likely to be boosting carbon dioxide levels in the atmosphere. Scientists are still working to better understand the changing interactions between atmospheric carbon dioxide and the carbon dioxide dissolved in the ocean. Colder regions are able to absorb more carbon dioxide than warmer regions, and as ocean waters warm, there is an increasing resistance to absorption of carbon dioxide. The role the oceans play in absorbing carbon dioxide is quite complex, and it's a two-way process, with carbon dioxide being absorbed in some parts of the ocean and released in others. Most recent studies indicate when carbon dioxide is released into the atmosphere, about 50% remains in the atmosphere, 25% is absorbed by land plants and trees, and about 25% is absorbed into certain areas of the ocean. In February 1958, the American public was introduced to the potential dangers of carbon dioxide, global warming, and sea level rise in a television series. The Bell Laboratory Science series aired its 4th TV episode, Unchanged Goddess, written and produced by Frank Capra. In the film, Dr. Research, played by Dr. Frank Baxter, explains that unrestricted carbon dioxide emissions could lead to a world where tourists in glass-bottomed boats will be viewing the drowned towers of Miami. Edward Teller was a Hungarian-born physicist who emigrated to the United States in 1935. He became part of the Manhattan Project, the team that created the first atomic bomb, and became colloquially known as the father of the hydrogen bomb. In November 1959, he was the guest of honour at a celebration in New York City to mark the 100th anniversary of the oil industry in America. The first oil well in the US had been drilled in Pennsylvania in 1859. The gala dinner was attended by 300 people from the oil industry and was organised by the American Petroleum Institute, then as now one of the most powerful trade groups in America. The title of Teller's talk was to be New Forms of Energy, but he said, first, before we talk about new forms of energy, we need to talk about burning fossil fuels. And he said, whenever you burn conventional fuel, you create carbon dioxide, and this transmits visible light, but it absorbs the infrared radiation which is emitted from the Earth. Its presence in the atmosphere causes a greenhouse effect. At present, if we keep on with our exponential rise in the use of purely conventional fuels, there will be a serious additional impediment for the radiation leaving the Earth. Our planet will get a little warmer. It's hard to say whether this be 1, 2 or 5 degrees, but when the temperature does rise by a few degrees over the whole globe, there's a possibility that the ice caps will start melting and the levels of the oceans will begin to rise. It was 63 years since Arrhenius had published his work on the greenhouse effect. In 1886, atmospheric carbon dioxide levels were 295 ppm. By 1959, they'd risen to 315 ppm. Probably the most important scientific study related to carbon dioxide emissions and climate change was established by David Keeling in 1958. In 1956, he joined the Scripps Institution for Oceanography at San Diego, California, to work with Roger Revelle. He'd already developed instruments able to reliably measure carbon dioxide in atmospheric samples with consistently reliable accuracy. At Scripps, he obtained funding to establish a base on Mauna Loa in Hawaii, 2 miles above sea level, and he started collecting carbon dioxide samples at the base in 1958. By 1960, he'd established that there was a strong seasonal variation in carbon dioxide levels, with peaks reached in the late northern hemisphere winters, and this can be seen from the saw cut appearance on the graph. A reduction in carbon dioxide occurs during spring and early summer each year as plants grow and deciduous trees come back into leaf, actively photosynthesizing in the land-rich northern hemisphere. As plant growth slows and leaves fall from the trees to be broken down by fungi and bacteria, carbon dioxide levels begin to rise again until the following spring. By 1961, Keeling had produced data showing that carbon dioxide levels were rising steadily in what later became known as the Keeling curve. In 1958, the levels stood at 316 ppm, and on March the 9th this year, it stood at 413.95 ppm. We now know that CO2 levels are higher than at any point in the last 800,000 years. In February 1962, this advertisement for Humble Oil appeared in Life magazine. Probably not one of their better advertisements. After the assassination of John Kennedy in November 1963, Lyndon B. Johnson was inaugurated as the President of the United States. Shortly afterwards, Roger Revelle, who'd served as science advisor to the Kennedy administration, drew Johnson's attention to David Keeling's results, and Johnson passed the information to the Congress within 2 weeks of his inauguration. Johnson's administration commissioned a report on the state of the environment in the United States from the President's Scientific Advisory Committee. The committee was led by Roger Revelle and was presented to President Johnson in 1965. The committee made a number of key points with regard to the impact of carbon dioxide. They reported that the concentration of carbon dioxide in the atmosphere and the ocean had increased by 7% over the previous 100 years. They considered that by the year 2000, the increase in atmospheric carbon dioxide would be close to 25%, and this could account for a temperature increase of 0.6 to 4 degrees centigrade. They warned of melting ice caps, rising sea levels, and acidification of water sources, and more. The report was distributed to not only the government agencies and officials, but also, due to its general interest, to the public. Later that year, the president of the American Petroleum Institute, Frank Ickard, addressed the annual meeting of the Institute. Commenting on the report, he said, "The warning is clear and dire, and the source unexpected. This report unquestionably will fan emotions, raise fears, and bring demands for action." The report further states, and I quote, "The pollution from internal combustion engines is so serious and is growing so fast that an alternative non-polluting means of powering automobiles, buses and trucks is likely to become a national necessity." In 1968, the American Petroleum Institute commissioned a report from the Stanford Research Institute, which was titled "Sources, Abundance and Fate of Gaseous Atmospheric Pollutants." They noted that CO2 emissions from fossil fuels were outstripping the natural carbon dioxide removal processes that keep the atmosphere in equilibrium. They considered that atmospheric carbon dioxide levels would reach 400 ppm by the year 2000. Carbon dioxide levels actually reached 400 ppm by 2016. The report warned that rising carbon dioxide would result in increases in temperature at the Earth's surface and could lead to melting ice caps, rising seas, and potentially serious environmental damage worldwide. The report considered that urgent research was needed into technologies that could bring carbon dioxide emissions under control. In 1978, President Jimmy Carter received a report from the Jasons. The Jasons are an independent group of elite scientists which advise the US government on matters of science and technology. Their report indicated that levels of carbon dioxide were predicted to double from pre-industrial levels by 2035 and to 2060 at the latest and to give a temperature rise of 2 to 3 degrees. Jimmy Carter was probably the most environmentally aware president the United States had. Maybe that came from his background as a farmer. In 1980, he gave what now looks to be a fairly amazing and forward-looking speech. He said, "Human identity is no longer defined by what one does, but by what one owns. But we've discovered that owning things and consuming things does not satisfy our longing for meaning. We've learned that piling up material goods cannot fill the emptiness of lives which have no confidence or purpose." In the speech, he announced an extra $10 billion over the following decade to strengthen public transportation systems. He said, "I'm asking you, for your good and for your nation's security, to take no unnecessary trips, to use carpools or public transportation whenever you can, and to set your thermostats to save fuel. Every act of energy conservation like this is more than just common sense. I tell you, it's an act of patriotism." Jimmy Carter became the first president to install solar panels on the White House roof. He failed to win a second term in the 1981 presidential election, being defeated by Ronald Reagan. Had he won a second term, the world could look a very different place today. In 1977, Exxon management was still being kept aware of the increasing dangers of climate change. James Black, the scientific advisor in the Products Research Division, told Exxon's management committee of top executives that emerging science showed that carbon dioxide levels were rising, likely driven by fossil fuel use, and such increases would boost global temperatures, leading to widespread damage. In 1979, the world's first climate conference was held in Geneva and sponsored by the World Meteorological Organization. It was one of the first major international meetings on climate change and concentrated on the science. The chairman was Robert M. White, who was a United States senior meteorologist. In his keynote address, entitled Climate at the Millennium, he said, "In a little more than 20 years, we'll be celebrating the year 2000. This millennium may well represent the ending of one era in the relationship of humanity to the planet and the beginning of another. The millennium may mark a fundamental change in the ability of the planet to sustain its people, or at least in the ways in which this will be done." In 1982, Exxon's Manager of Environmental Affairs circulated a document to Exxon's senior management on the greenhouse effect. The covering memo indicated it could be shared internally to aid discussion, but was not to be passed externally. Exxon used one of their oil tankers, the SO Atlantic, in their studies into the capability of the ocean to absorb increasing carbon dioxide emissions. In his report to senior staff, Glazer acknowledges that fossil fuel combustion, along with the clearing of rainforests, are contributing to rising concentrations of atmospheric carbon dioxide. He estimated future temperature rises and indicated that the greenhouse effect would probably be detectable within the next 20 years. He considers there is currently no unambiguous evidence that the Earth is warming, although within a few years Jim Hansen is about to produce the evidence. Oil companies have been carrying out research on carbon dioxide and climate change since the 50s. Investigative journalists and Exxon staff and whistleblowers have brought much of this information to light over the past few years. In 1982, Exxon predicted that by 2060, carbon dioxide levels would reach around 560 parts per million, double the pre-industrial level, and that this would push the planet's average temperatures up by about 2 degrees centigrade over the then current levels, and even more compared to pre-industrial levels. Clearly, Exxon's own scientists and their senior management understood where the current direction was taking the world. This makes their efforts to discredit the science 20 years later so appalling and unforgivable. Shell had also carried out its own research and clearly knew the implications of continuing down the fossil fuel burning path. One of their reports is available on the internet, and in a legend to one of the modelling graphs, shows comments that emissions were likely to pass 600 ppm in the third quarter of this century. In the summary page of the report, they indicate A doubling of carbon dioxide emissions, i.e. 600 ppm, would increase global temperatures by 1.3 to 3.3 degrees centigrade. They point out that other greenhouse gases could increase this to 1.5 to 3.5 degrees centigrade. They point out that models indicate that this could result in changes in sea level, ocean currents, precipitation patterns, regional temperatures, and weather. They say that by the time global warming becomes detectable, it will be too late to take effective countermeasures and to reduce the effects or even stabilise the situation. The likely timescale of possible changes does not necessitate immediate remedial action. However, the potential impacts are sufficiently serious for research to be directed more to the analysis of policy and energy options than to studies of what we will actually be facing. Shell, like Exxon, clearly knew where our continuing dependence on the use of fossil fuels was going to take us. In the 1980s, Jim Hansen, the director of the NASA Goddard Institute for Space Studies in New York, was to make a significant contribution to the science and to the debate. In 1981, following the 1938 study of Guy Callendar, he analysed the records of surface air temperatures at meteorological stations across the world from 1880 to 1981. His conclusion was that warming over the past century was now clearly detectable and stood at 0.5 to 0.7 degrees centigrade. An update in his 1988 paper indicated that the 4 warmest years on record were all in the 1980s, the warmest being 1981 and 1987. In 1988, Hansen was asked to testify at a US congressional meeting on June the 23rd. The transcript of Hansen's evidence is available, as is the introduction from the Arkansas Senator Dale Bumpers. Bumpers said, "Nobody wants to take on the automobile industry. Nobody wants to take on the industries which produce the things which we throw up into the atmosphere. They don't want that stopped, and that's understandable. But what you have are all these competing economic interests pitted against their very survival." In his testimony, Hansen said he was 99% certain the Earth was warmer than it had ever previously been measured. There was a clear cause and effect relationship with the greenhouse effect. And due to global warming, the likelihood of freak weather was steadily increasing. In an interview with The Guardian in 2018, Hansen said, "All we've done is agreed there's a problem. We agreed that in 1992 at the Earth Summit in Rio, and we re-agreed it again in Paris. What we haven't done is acknowledge what's required to solve it. Promises like Paris don't mean much. It's wishful thinking. It's a hoax that governments have played on us since the 1990s. David Keeling's monitoring of atmospheric carbon dioxide levels since 1958 at Mauna Loa had provided valuable and unequivocal evidence of the ongoing annual increase in carbon dioxide levels. To determine what atmospheric levels have been historically, scientists have analysed air bubbles trapped, frozen, in ice cores. Drilling and analysis of ice cores from sites around the world have been carried out since the 50s, notably from Greenland and Antarctica. But it's not until the late 1970s that a reliable extraction method was developed. Analysis of the changes in the concentration and proportion of rarer isotopes of hydrogen and oxygen provide a means of dating the point where the air was trapped, in a similar manner to which we use carbon dating. Analysis of frozen air bubbles has provided a detailed record of carbon dioxide change going back hundreds of thousands of years. Two of the first publications were from groups of Neftel and Friedli, both Swiss groups, who studied the atmospheric carbon dioxide record for the past 200 years using ice cores from Antarctica. Both concluded that atmospheric carbon dioxide concentrations were about, in 1750, were 280 parts per million by volume. The Australian group of Etheridge and his colleagues in 1996 analysed ice cores from Antarctica, and their graph demonstrates that carbon dioxide and methane were both relatively stable over the past millennium, until the mid-19th century, when both began to rise significantly. Studies of much deeper ice cores by the US National Oceanic and Atmospheric Administration have enabled analysis of climate fluctuations over the past 800,000 years. Their data indicates that historical levels fluctuated between approximately 180 to 280 ppm and last reached 300 ppm some 300,000 years ago. Study of ice cores and other geological and geophysical analysis indicates that over the last 2 to 3 million years, the Earth has cycled through ice ages approximately 90,000 to 100,000 years apart, and these are interspersed with short warmer interglacial periods. The onset of an ice age is related to Milankovitch's cycles. Milankovitch was a Serbian mathematician who identified in 1924 that there were regular changes in the Earth's tilt and orbit, which combine to affect which areas on the Earth get more or less radiation. The Earth was anticipated to be heading towards a future ice age, but global emissions have now prevented this. In 1800, the concentration of atmospheric carbon dioxide was about 283 ppm. Almost a century later, when Svante Arrhenius presented us with his picture of the greenhouse effect, it had reached 295 ppm. And when David Keeling established his monitoring station at Mauna Loa in Hawaii in 1958, it was 315 ppm. When Jim Hansen addressed the Congress in 1988, it had reached 366.7 ppm. And while you're sitting listening to this, it sits at around 414 ppm. As Sherwood Rowland said, up until about 1990, the climate of denial and misinformation had not developed. The arguments which they were largely between scientists and based on the facts and the results of study and analysis, and mainly took place at scientific conferences or in the peer-reviewed scientific journals really looked at by the non-scientist. Part 2 of this presentation covers the period from 1990 to the present day, the period when climate scientists continued to develop more evidence, refine their predictions, and monitor the changes to the planet as climate change began to accelerate. When world leaders failed to grasp the significance and urgency of the problem with which they had to deal. And it was the period when the denialists, the vested interests, worked to impede any meaningful response, and political affiliation began to influence the debate. Thank you for listening.